Thank you very much. So before we get started, I would like to do a couple of introductions. So first, is my clicker going to work? Yep. First, I'd like to introduce Ashley. He's going to hate me for using this photo, but he is one of the software developers on one of our engineering teams, and he was heavily involved in the actual physical move of our SDKs into Kotlin Multiplatform. He's kind of the brains behind this talk, and also was with the company for many years, has a lot of experience around the history of code share attempts and everything else. So I spent many hours kind of bugging him to get information for this talk. So definitely need to thank him for that. And then there's me. I was an Android developer for many years. I then moved into developer relations as an Android developer advocate. And last summer, I turned to the dark side and became a manager, managing the Client SDK DevRel team. You can find me over on Mastodon or anywhere else as Dev with Zachary, if you'd like to. So before we get started, a couple of takeaways for this talk. Unfortunately, not pizza, but hopefully I haven't made you too hungry. First, I want to start by saying this isn't a code talk. We've had a lot of really great code talks today. I've certainly enjoyed them. But instead, this is a kind of real-world example of an engineering team who have built a library in Kotlin Multiplatform. And hopefully, with some good takeaways from that, you'll be able to learn from some of our pains in doing that. Have a look at the history of the SDKs, so hopefully that will give you a good idea of kind of some of the previous pains that we've had, and probably you share if you've done any code share in the past, and also the past code share attempts. Taking that, you should hopefully also see the success of where we are now. The main changes that we have found outside of just the physical code, what's actually changed about the engineering teams, what's changed about the structure of the SDKs, and kind of those more abstract things that have made a big difference moving into Kotlin Multiplatform, and also where the SDKs are now. Plus a few extras, if we have time, for some surprise improvements that certainly on the team no one really considered until it happened. So before we get kind of into that part of the talk, I need to give you a little bit of background so you understand what the SDKs are that we've moved over. And they are the Vonage Client SDKs. So what are those? Well, Vonage does a huge range of communication APIs, things like voice, video, SMS, and then services built on top of that, two-factor authentication, all those sorts of things. And we have a range of SDKs for a range of platforms. So when we say client SDKs, we mean specifically Android, iOS, and JavaScript. We also have what we'd call server-side SDKs, things like PHP, Python, and all those sorts of languages. Unfortunately, those aren't written in Kotlin. But all our SDKs really are just wrappers for the APIs. All our APIs are RESTful APIs. They use WebRTC for voice and video. You can just use the APIs if you want. All the open API specs are available. That's an easy thing to do, but one thing that a lot of people want to be able to do is use those APIs in a more native-friendly way. So if you're writing an Android application, you want to be able to use a nice Kotlin library to call those APIs, and you don't have to worry about the JSON that gets returned or the different authentication headers you have to use, or all that sort of stuff. And that's kind of where I come in and our team comes in. Within the developer relations, we build those SDKs. So to us, developers are our world, and that's who we are thinking about. We try and kind of smooth over some of those issues that might be existing in legacy APIs and all those sorts of things that we all know happen when it comes to APIs. So the SDKs are a better way to do that. And so if we're talking about that, with that in mind, it's time for a little bit of a history lesson. And a long time ago, in a tech company far, far away, there was a startup called Nexmo, which some of you may have heard of. It was a European startup that did communication APIs. I'm sure you can see where this is going. They had 3 native SDKs for Android, iOS and JavaScript. They were completely separate. There was no code share at all. And one of the biggest gripes was that this was really incredibly difficult to test for. If there was a new change in one of the APIs, all 3 SDKs had to support that, and you had to test 3 times. You had to do everything 3 times. Any new feature was built by 3 different people. So even if you had the perfect API spec, you had the perfect kind of design, there were always going to be kind of small things that each of the teams did differently for the respective platforms. And just purely from engineering power, it was 3 times the work to implement anything. So, fast forward a few more years, Nexmo was bought by Vonage. Nexmo became the Vonage API platform. And this was the perfect opportunity for a rewrite. It was time to kind of take that opportunity and make something better that started to utilize code share. And this was in about 2018, so this was a few years ago. And actually, the JavaScript team thought, there's this cool new thing that's just been released. It is alpha. It is very early. But let's give it a go. Let's have a look at Kotlin Multiplatform. Very early stage. And the other issue was that the team really wanted to rebuild everything, the whole SDK in Kotlin and in Kotlin Multiplatform, and leave no platform-specific code. This was their goal. It failed very quickly. A combination of the Kotlin Multiplatform just not being where it needed to be to support a lot of the things that they wanted to be able to do across all 3 platforms, and just the inherent design idea of having everything in that proved it incredibly difficult to the point where it failed. But we still really wanted code share. We still wanted to at least reduce some of the effort that was involved in supporting these SDKs. And that's where C++ came in. And you can already see where the pain is coming from. It allowed for code share, which is fair. And it was also obviously a much more mature option in its way. And you could basically build a base level with platform-specific code written on top. It had kind of all the fundamentals of what you'd like to see from CodeShare. We also had some internal resource around this. So we had people that knew how to write C++, but not many of them. But this is where we went to. This is where it was implemented. We got CodeShare. It was great, right? I mean, no. It was actually, it was not great. It was actually kind of the opposite of good to the extreme. What we ended up with is kind of something like this diagram. And it doesn't take a mathematician to realize that instead of trying to reduce the amount of code that was across the platforms, and we started with 3 SDKs, a JavaScript one, an Android and iOS, and we wanted to reduce the amount of code there was, well, actually, we ended up increasing it by adding a 4th layer, which was the C++ layer. And it didn't actually really reduce much of the 3 other layers. So now instead of having 3 teams supporting an SDK, we had 4 teams supporting SDKs. It also really wasn't accessible to everyone. I don't know how many of you have had the pleasure of building in C++, but compared to things like Kotlin and JavaScript, it's certainly miles apart, and a lot of those developers just didn't have the skill the skill set to access that code and work on it. And that kind of meant that we were very dependent on specific people working in that kind of C++ code share, and therefore, if they were on holiday, well, we'd have to wait for a release. And it really sort of slowed down the release cadence, which when you're building a library is incredibly important. We want to be able to have reactive code share, so reactive SDK builds. So when there's a bug, we get a new release out. When there's a new feature in the API, the SDK follows quickly. That was very difficult to do like this. So let's do a rewrite for the second time. But what were we going to do? Well, realistically, what we wanted is at least something much closer to this diagram. We wanted a decent chunk of the code base to be in the code share, And then the platform-specific stuff was kind of whatever just needed to be platform-specific. Co-share, but better. We kind of came on the conclusion that really the best way to do that is keep all the business logic in the code share and leave the lower level platform stuff to the platforms. So that was kind of the very rough idea of what we wanted to achieve. The next question was, what language could we achieve that with? Based on the skills that we had available internally and the kind of maturity of the options. So really we came up with 3 options within the team. The first being still C++. It was a valid suggestion to actually just rewrite that and use it for the business logic and it be still written in C++. So that was presented to the team, and actually kind of unanimously there was a very quick answer that they gave. No, please, no. It wasn't viable because the fact that there was still going to be that dependency on specific people, there wasn't the wider arching kind of support within the team, and also I think there was also maybe a bit of trauma around having to kind of support that previously that they just didn't want to do. So the second option actually was Rust. It was very powerful. I mean, for those that have used Rust, they know that and will quite happily say that. And it was also quite good for CodeShare. We've had an example earlier today of how you could go about using Rust with Kotlin Multiplatform, actually. But there was some issues that they started to highlight. There was at the time the issue of kind of binding between the Rust layer and then the native code, which would still need to be there to some level. And within the team, the kind of tooling and the ability to actually make this thing happen was quite unknown, and that was kind of a little bit scary because we didn't want to fall into another C++ trap of being dependent on specific people and having to learn something a lot. So in came Kotlin Multiplatform. This was now sort of 2021-ish. COVID kind of skews my perception of time, but somewhere around there. And there was obviously a much more mature option than when it was previously looked at. It was also very good for shared code base. Binding issues were a much cleaner and easier thing to achieve. So the engineering team, who obviously also, at least a third of them, already had Kotlin knowledge because they were building for Android, they said, right, let's prototype, let's give it a go, let's see if we can achieve the thing that we wanted to achieve, something like this. So come December 2021, as we all know, as soon as you start getting close to the holidays, no one wants to actually do any real work, no one wants to be fixing bugs, no one wants to do anything like that. So instead, the team kind of hid away and built a prototype instead, did something a bit fun. And they were very careful, even in the prototype, about what was going into the shared code. This was definitely a mistake from C++. The Kotlin Multiplatform was only for the business logic. Platform-specific stays out. And what do I mean by the platform-specific? What was platform-specific for us? And really, it was the networking layer. We actually already had very good HTTP clients, WebSocket, WebRTC clients for Android and iOS, and obviously a lot of stuff was already built into JavaScript and the browser. So that was kind of what we wanted to keep out of the C++, and I think we did that quite well. So that stuff would just be exposed behind interfaces back to Kotlin Multiplatform, and we'd let the platforms worry about that. So the prototype was worked on at the end of the year into January, and it worked. It was successful. It was basically just taking a few of our APIs. It wasn't a full SDK, but it proved that you could do the things we needed to do in a much nicer way. Then we had drama, like all good stories. Ashley, absolutely, he dared to have a child, which obviously put a dampener on everything. He went on paternity leave. Obviously, it was a lovely thing, and we're all very happy for him. But it did kind of hold the project for a while because he was a big driving force of this, and it was a big kind of hit. We also had team members leave. It was the new year. it happens. You know, people leave the company, and what that meant is the team that was left had to focus on fixing bugs in the current SDK. There wasn't the bandwidth to build something new. They had to keep supporting this thing that people were already using in production. It wasn't like we could just drop support and move on. But wait. By doing this, the team are reminded of the painful process of supporting the current SDK, of how painful it is to build new features, fix bugs, and all that sort of stuff. And just as they are kind of starting to really feel the pain, Ashley returns to triumphant fanfare. He has come back, he is the savior, and the team kind of say, look, we really need to do something now. We really need to come up with a plan for this year. We need to build something. So, you know, in the inspiring words from Ashley, sod it, let's do it. It was time to build a new SDK. But what actually needed to happen to make that, make that possible? We had a prototype, but where did we need to go from there? Well, we'd already previously kind of focused on iOS and Android. We needed to build something in JavaScript as well to make sure that it was going to be functional. We needed to check that. But actually the process there was fairly smooth, and that wasn't a problem. So that was actually really all that changed. All that then happened is adding in the new APIs and other stuff to build out a full SDK that was kind of feature parity with the previous one. So that's when I kind of asked the team, what were the main changes to your workflow, to the team's workflow, all those sorts of questions, as opposed to clearly what were the main changes to the code the thing was rewritten. But what changed in their process? And hopefully these are kind of some points that might get you thinking about whether this is something that you can do in the future. Obviously, the first one was they had to learn Kotlin. The team at that point merged into one large team, and for the Android side, well, they were off having a party for weeks because they already knew all this. But iOS and JavaScript devs, they had some learning to do. They had a lot of catch up, and that was a big investment for the company to make sure that they did. They had the resources they needed, they could build this. The other thing, of course, was we had to go all in on a build system. We obviously went with Gradle. It made iOS developers very sad. I think there was a few people still crying out for makefiles. It was kind of a little bit of contention for a while, but everyone got on board in the end, and it's definitely a big change to the whole process. And the other thing was the actual tool, the moving in tooling, the shifting in tooling. Like I mentioned, we had C++ developers. We had people that were used to being able to just spin up Vim or a text editor of their choice, write some code and build it. They didn't quite grasp just how big Android Studio is, and some of the issues when projects get large, as we've heard about earlier today as well. So there was a lot of relearning. I definitely wouldn't recommend trying to use any of those developers' laptops because all their key bindings are completely changed and it's very strange. I've had a look at it before, but because they're so used to using things like Vim, they've completely remapped their Android Studio, which is fine. So yeah, where are we today? Well, we have released the SDK. It is actually available. We've split it out into two modules. We have the voice component and we have the chat component as separate things. Chat component is releasing the end of this quarter, but we have voice out there for people to actually use. And so now that we are right now here in the last couple of, last sort of month, I've kind of, again, I asked the question to the developers again, what changed? What happened? What have you learned about this process, and what would be useful for people to hear about? I think one thing that they kind of didn't really consider necessarily at the time was that you have to keep up to date with Kotlin updates. Some of the developers are very much used to using things that are a bit more stagnated, slow developing languages, C++, that you don't have to worry about the new and exciting things because kind of everything's already there and it's done. So there is definitely resource that's going into making sure that the team keeps up to date with Kotlin. It can use the new features as they're released. It can do all those sorts of fun stuff, but it's something you have to consider. Importantly for them, the original pain point of consistency completely removed. You can now just write once and it work everywhere for our SDK. All the platform code is actually now doing is exposing the functionality of the Kotlin Multiplatform code. What that kind of has meant is that we have more time to work on that API contract between SDK and developer, which at least I certainly think it means that the new SDK is much nicer to use, both as an Android developer, as an iOS developer, or as a JavaScript developer. We have the time to kind of fine-tune and improve that experience, whereas previously it was kind of just, here it is. The other great thing is that now everyone knows Kotlin, which I mean, just as a thing, I think is great. From the previous talk, everyone should know Kotlin. But it does mean that everyone on the team can build a feature. Everyone can own a feature from its design all the way through. They have that responsibility, and we're not dependent on any specific person. We're not dependent on multiple people deploying the same feature. So there's more ownership within the team as well to actually kind of take that through the whole process, which we wouldn't have had before. Another one which I could give a whole separate talk on is that we have moved to a mono repo for the SDK, and in terms of keeping the whole team synchronized and everyone having visibility and access to the whole SDK code base, it's much better. I know that we could definitely have an argument about whether mono repos are good and the times that they are good, but in this situation it's worked incredibly well for us. And kind of the final point, we have tests now. And as you all know, tests are the key to saving developers time, effort, energy, and as developers are our world, that's how we've saved the world with Kotlin Multiplatform. But honestly, also, it's just really nice to be able to rely on tests and they actually work. So yeah, that is what we've done with Kotlin Multiplatform. If you would like to check out the SDK, please do. The QR code will take you to a GitHub community, which will give you the kind of tutorials and show you how to get started with the SDK with some sample apps. There's also a coupon code. If you do want to sign up for a developer account, you get 10 euros credit, and you can send SMS messages and call yourself and all that sort of fun stuff. So please do check that out if you'd like to. But other than that, thank you very much. As always, my slides are available on GitHub if you'd like them. Thank you.